Welcome to proving the Pythagorean theorem using similar triangles. I want you to try to write this proof by yourself as much as you can and as many steps as you can before you play the rest of the movie. So press pause and see if you can do it by yourself. If you get stuck, go ahead and press play and try to catch up to the spot where you are stuck in, and then continue on by yourself as much as you can. So before we do anything else, we are going to rename each side just to make it a little bit easier. We currently have the three vertices, the three angles named in capital. So M, N, O capitalized are the angles, and the lowercase are going to represent the side lengths. Across from angle M is lowercase m to represent this side, and so on and so forth. Across from angle N is side N. Same with angle O. Across from him is side O. And this is the theorem we're going to try to prove, that N squared plus O squared equals M squared. So here we go. The first step that we always need to do for this proof is to draw an altitude from angle M down to the other side. And an altitude is just a line that forms a 90-degree angle with one side of the triangle, and it drops down from the vertex at the other side. And we're going to call the point where it intersects P. And we're also going to notice that we have now created three triangles. A small triangle here, N, M, P. We're going to name this little segment here P. A medium-sized triangle, P, M to O, and we're going to name this medium segment here Q. And of course we still have the large triangle, N, M, O, and M is still the entire length of this other side. Now here are the first two main mathematical steps that we're going to do. Step one, we're going to compare the big triangle to the medium triangle. We're going to show that these are similar to each other, and then we're going to get corresponding sides equal to other corresponding sides. Step two, we're then going to compare the big triangle to the small triangle, and we're going to show that they are also similar to each other. So let's get started. First step, we're going to compare the medium triangle to the big triangle. So to make it clear for us, I took the medium triangle, which is here shaded in purple, and I just made a replica down here, same exact size. And I took the large triangle and I made a replica down here. And you also want to notice that both the medium triangle and the large triangle share this angle O. It's the exact same angle, so I marked it congruent in both. Angle O is congruent to angle O. And of course we have this 90-degree angle and this 90-degree angle. Now since two of the angles are congruent, we can say by AA triangle similarity theorem that both triangles are completely similar to each other as well. And if you don't believe me, all we really need to do is take this medium triangle and rotate it around so that the right angle, is on the bottom, just like the other one. And I think you can begin to see how they actually are similar, just not facing the same direction at this moment. So moving on, we've established that they're similar, and we now need to set up a proportion. So we're going to look at the corresponding sides of the medium triangle and the big triangle, and we're going to set it equal to the other pair of corresponding sides. The first sides that correspond are the hypotenuses, which of course if you look at the right angle, the hypotenuse is the side across from it. It's just another fancy name for the side across from the right angle. So in the medium triangle, the hypotenuse is side N. And let me get that showing for you. The hypotenuse in the medium triangle is side N. In the big triangle, the hypotenuse is across from the right angle, which is here, so it's side M. There's our first set of corresponding sides. Now we're going to look at the between side, between the two angles that we know. In the medium triangle, between the right angle and angle O is side Q. And in the big triangle, between the right angle and angle O is side N. So this equals this. We're going to save that and use that in just a minute, but before we do that, we're now going to compare the small triangle to the big triangle. And to help us, I've shaded in the small triangle, and I've done the same thing as before. I replicated the small triangle down here, and the big triangle I replicated down here. Please notice this angle here is also going to be 90 degrees. If this is 90, then this also has to be 90, because 90 plus 90 is 180, which gets us this straight line. Also notice that angle N is the same in both triangles, in the small triangle as well as the large triangle. So I've labeled angle N as congruent to angle N. And again, since two of the angles are congruent, the triangles are similar, and we can compare corresponding sides. So let's do what we did before. Let's set up a proportion. The hypotenuse in the small triangle is again across from the right angle, so that would be side O. The hypotenuse in the big triangle is again across from the right angle, so that would be side M. Then we'll look at the between side of the small triangle. So between the 90 degree and between angle N is side P. Over here, the between side between the 90 degree and angle N is side O. There's our proportion. So now we're going to take our two proportions that we just made, comparing the big triangle to the medium triangle and the big triangle to the small triangle, and we are going to cross multiply. So we do n times n equals m times q. And we can simplify n times n to be n to the second power equals m times q. Then on the other proportion, we do the same things. O times O equals m times p. And we can simplify that again. O times O can be written as O squared equals m times p. Now our third step, oh excuse me, that was our third step. Our fourth step is our final step. As you notice, we're almost to Pythagorean Theorem. Just a few steps in between. The fourth step is we're going to add those two equations together. And the reason we're able to do this is because whenever we add something to one side of an equation, we just have to add an equivalent amount to the other side. Okay? And I'm going to organize this like our friend Tyrese Freeman has shown us, to keep the equal sign centered, and things on the left, things on the right. So if on the left side I want to add O squared, on the right side I also have to add O squared to keep it balanced and equal. But MP is the same thing as O squared. So if I add O squared on the left and MP on the right, I have added equal amounts to both sides of the equation. Therefore, I'm allowed to do this. So on the left side, when we add these up, we get N squared plus O squared equals. And on the right side, we get MQ plus MP. Now, if you notice, we are almost to Pythagorean theorem. We already have N squared plus O squared, which is what we want here. The only thing that we need to figure out is how to get m squared from the right-hand side. So we're going to leave the left side as is, n squared plus O squared. And over here, all we need to notice is that both terms have been multiplied by an m. So we can factor out an m, and we can rewrite it as this, that q plus p, both together, have been multiplied by the quantity m. We factored it out. Now all we need to do is one last step. Going back to our original diagram, we notice something. Q plus P together actually equal side M. P and Q together are the same as M. So Q and P we're going to replace as M. So we have M times M, and then we can just simplify M times M as M squared. And you have just proved this nifty relationship called Pythagorean theorem. N squared plus O squared equals M squared.